Influence lines are fundamental to structural engineering. They help engineers design structures that can withstand various loads. By understanding how loads move across a structure, engineers can predict the worst-case scenarios. This knowledge is crucial for designing safe and efficient bridges, buildings, and other structures. Influence lines provide a visual tool for analyzing these load effects. An influence line is a graph that shows how a specific point on a structure responds to a moving load. It plots the value of a particular force or moment at that point as a unit load moves across the structure. Influence lines differ from static load diagrams. Static load diagrams show the effect of fixed loads on a structure. Influence lines, on the other hand, illustrate the effect of a single moving load on a specific point. Let's consider a simply supported beam to understand how to construct an influence line. We want to determine the influence line for the reaction at one of the supports. First, we place a unit load at a variable distance x from the support. Then we calculate the reaction at the support for different positions of this unit load along the beam's length. Plotting these reaction values against the corresponding x values gives us the influence line for the reaction at that support. Influence lines have broad applications in structural engineering. They are graphical representations that show how different points on a structure respond to loads applied at various locations. This makes them invaluable tools for engineers. They are essential for designing bridges subjected to moving traffic loads. By using influence lines, engineers can predict how the bridge will behave under different traffic conditions, ensuring safety and durability. By analyzing the influence lines for critical points on a bridge, engineers can determine the maximum stresses and deflections caused by traffic. This analysis helps in optimizing the design to handle peak loads efficiently, preventing structural failures. Similarly, influence lines are crucial for designing cranes. Cranes are complex machines that lift and move heavy loads, and understanding the forces involved is key to their design. They help determine the maximum forces in the crane's members as it lifts and moves loads. This ensures that the crane can operate safely under various conditions, preventing accidents and equipment failure. Influence lines are also used in designing buildings, especially for analyzing the effects of wind loads and moving equipment. In high-rise buildings, wind can cause significant sway and stress. Influence lines help engineers design structures that can withstand these forces, ensuring stability and comfort for occupants. Additionally, influence lines are used in the design of other structures like dams, towers, and even aircraft. They provide a comprehensive understanding of how loads affect different parts of a structure, leading to safer and more efficient designs. Section 5. Influence lines versus moment and shear force diagrams. While influence lines, moment diagrams, and shear force diagrams all help analyze structures, they serve different purposes. Understanding these differences is crucial for structural engineers to ensure the safety and stability of their designs. Moment and shear diagrams depict the internal forces like moments and shears at every point along a structure for a specific fixed load. These diagrams are essential for determining where the maximum stresses occur, which helps in designing the structural elements to withstand these forces. Influence lines, however, show how a particular force or moment at a specific point varies as a unit load moves across the structure. This is particularly useful for structures subjected to moving loads, such as bridges or cranes, where the position of the load changes over time. In essence, influence lines analyze the effect of moving loads, while moment and shear diagrams analyze the effect of fixed loads. By using both types of diagrams, engineers can gain a comprehensive understanding of how different loads impact a structure, ensuring that it can handle both static and dynamic forces effectively. This dual approach allows for more accurate and reliable structural designs, ultimately leading to safer and more efficient constructions. Whether it's a high-rise building, a long-span bridge, or an industrial crane, the combined use of influence lines and moment and shear force diagrams is indispensable in modern structural engineering. Section 6. Practical example. Influence line for a simply supported beam. Let's consider a simply supported beam of length L. This type of beam is supported at both ends, allowing it to freely rotate and translate vertically. It is one of the most common types of beams used in structural engineering due to its simplicity and effectiveness. We want to determine the influence line for the bending moment at the midspan of the beam. The midspan is the point exactly halfway between the two supports, where the bending moment is often of particular interest in design and analysis. To do this, we place a unit load at a distance x from the left support. This unit load represents a moving load that can be positioned anywhere along the length of the beam. Using the principles of statics, we can calculate the bending moment at the midspan for different values of x. Statics principles involve analyzing the forces and moments acting on the beam to ensure equilibrium. Plotting these moment values against the corresponding x values gives us the influence line for the bending moment at the midspan. The influence line is a powerful tool that shows how the bending moment varies as the load moves across the beam. This graphical representation helps us visualize how the bending moment at the midspan changes as a load moves across the beam. By understanding the influence line, engineers can predict the maximum bending moment and design the beam to withstand these forces, ensuring safety and stability in structures. Influence lines are not only useful for bending moments, but also for shear forces and reactions at supports. They provide a comprehensive understanding of how different loads affect the structural behavior of beams. In practice, influence lines are used in the design of bridges, buildings, and other structures where loads move across spans. They help engineers optimize material usage and ensure that structures can handle varying loads efficiently. By mastering the concept of influence lines, structural engineers can enhance their ability to design safe, efficient, and reliable structures. This knowledge is fundamental in the field of structural engineering and plays a crucial role in the successful completion of engineering projects. Section 7. The importance of influence lines in safe and efficient designs. Influence lines are indispensable for designing safe and efficient structures. They help determine the maximum forces and deflections that a structure might experience due to moving loads. This information is crucial for selecting appropriate materials and dimensions for structural members. By optimizing designs based on influence line analysis, engineers can ensure the safety and longevity of structures while minimizing material usage and costs. Section 8. Conclusion. Influence lines are a powerful tool in structural engineering. They provide a visual and analytical method for understanding the effects of moving loads on structures. From bridges and cranes to buildings, influence lines play a critical role in ensuring structural safety and efficiency. By mastering the concepts of influence lines, engineers can design robust and reliable structures that withstand the test of time and usage.